Welcome back to the second lesson in the Unity game development series. In the previous lesson, we installed the Unity editor and wrote our first line of code to make sure everything works. We used this line of code to send a message to the console. This was not really a result that we are proud to show to friends and family. But we can use this concept of sending a message to the console to get acquainted with variables. A variable is a way to efficiently use a value in our programming code. I think it's easiest if I show it. Let's start a new Unity project from the Unity Hub, which we'll call Lesson 2. Again, we'll use a 3D template. When the project is started, we place a cube in the hierarchy, just like in the previous lesson, and we attach a new script to this cube that we call test. This is a repetition of the previous lesson, so I'm going to go through it a little faster. If it goes too fast for you, you can go back to the previous lesson to refresh your memory. Again, we place a debug.log code in the start method and save the script. Now we can test whether the message appears in the console when we press the play button in the toolbar. We have the same result as we ended last lesson. Let's tweak something about the debug.log code. We can put any text we want in quotation marks. And if we save the script, we send the new message to the console, instead of changing the message between the quotation marks. We can also use a variable. To do this, we first need to create it. We do that above the starting method, between the highest level of the curly brackets. Here we write string variable name equals Unity Game Development Tutorial, Lesson 2. What have we written here? We created a string variable and named it variable name. It is important that the name is written together without a space. A string is a data type. We need to specify which value we want to give the variable. When working with text, you use the data type string. In addition to creating a variable, we will also immediately add a value to it. We do this by placing an equals symbol after the declaration, followed by the value. Characteristic of the data type string is that the start and end of the value is indicated by means of quotation marks. Between these quotation marks, we enter the actual value. And we conclude this statement by placing a semicolon. And now we can use this variable in our earlier debug.log code. Between the parentheses, we can put the name of the variable. If we have done it correctly, we can test it in the Unity editor. After saving the script, if we press play, the value of the variable should appear in the console. Now, what is the advantage of using a variable and not just directly hard-coding the value in the debug.log? In this example, we only use the variable in one place, so it is indeed difficult to call this an advantage. But if you use the player's name as a variable in your game, it will appear in several places in the game. With the help of a variable, you can easily reuse this value in multiple places. Moreover, the name variable was not chosen by chance. Suppose the player changes his name. Then this new name would have to be changed in all places where it is used. If you change the value of a variable, automatically, this changed value is immediately replaced wherever the variable is used. Maybe a nice moment to show the power of C# in combination with Unity. We can also adjust the value of the variable in the editor. If we write for the declaration of the variable in the script, the keyword public, now we can change the value of the variable in the editor. We have used the string for text, but we will also have to work with numbers regularly if we enter a number in the editor. It seems as if it is also possible to work with numbers in this way. But here we are being fooled a bit by Unity. We can show what's going on by placing a calculation in our script. In the debug.log, Let's try this for fun. Change it to debug.log variable name plus variable name. This is technically correct, but it will not produce the desired result if you add a string twice. The value is simply placed twice in a row. And since we have indicated that our number is a string, the value will be placed twice in a row. If we want to create a variable that really functions as a number, we need to use a different data type. Under the previously declared variable, let's declare a new variable. This time it will be an int variable. Public int value variable equals 100. We also made this variable immediately accessible in the editor by making it public. Then we write down the keyword int, short for integer, and give it a name, and we gave the variable a value of 100. And we end with a semicolon. Now we can use the debug.log to send the new int variable to the console. If we now add the int variable to itself, it works just the way a number should behave. When we enter play mode in the Unity editor, we should see a value of 200 appear in the console. Until now we only sending messages to the console. This way we have learned about variables and the data types string and integer. But I think it's time to make something we can actually use. Let's make an app that counts how many people have entered a room. Maybe this is used to prevent a fire safety hazard. We need a button we can press every time we let someone enter the room. And we need a text component where we can show the number of people we have let in. First, we delete the cube from the hierarchy. Right-click with your mouse and select Delete. We don't need this game object for our project. Before we can get started, we first need to introduce the canvas and UI elements. A canvas is a container in which we can place UI elements. With UI elements we can let the user interact with. Examples of UI elements are buttons, text component, text fields, sliders, switches. Right-click in hierarchy and select UI. From the pull-down menu select Canvas. A canvas is added in the hierarchy. In the inspector are a few render modes for the canvas, but we leave the mode to screen space overlay. This way the canvas is rendered on top of the scene. If the screen is resized or changes resolution, the canvas will automatically change size to match this. Select the canvas in the hierarchy. And while selected, right-click to add a new UI element. From the pull-down menu select Text. TextMeshPro. If needed, select Import to let Unity process the systems needed for us so we can use TextMeshPro. Now, we are adding a new script to the canvas. We'll call this script counter. We can use this script to change the text in the text component. If you want to see the result, we need to change the background of the main camera. The default background is skybox, but we want a solid color. Now we can see the text component. In the middle of the game view appear. The text shows new text. Off the script will change this value. Let's open the script by selecting the canvas and double-clicking on the script in the inspector window. In the script we need to import a new library. If we want to use TextMeshPro, type at the top of the script using TMPro semicolon. And now we are going to make a new public variable of the data type TextMeshPro UGUI, and we give this variable the name text container. In the start method, between the curly brackets we type TextContainer.text equals between parentheses test. We end this statement with a semicolon. Now we can save the script and return to the editor. If we try to run the project by pressing the play button, we get an error. Let's take a look at this error. It's trying to reference an object that's not set. Exit the play mode by pressing the play button again. If we select the canvas, we can see that the public variable text container holds no value. We need to reference the text component. We can simply drag the text component from the hierarchy to the field in the inspector of the canvas. If we enter play mode, we can see the new text. In the game view, the text is changed to the value text. So now we have a text container that holds a text property that we can change with our counter script. But we don't want to change the value of the text property by changing the script. We want to change this value outside the script. Open the counter script. We need a public variable that we can change. We add a public string variable to the script that we call text. This text variable is placed in the start method as the value of the text container's text property. We can now change the value of the text property of the text component in the inspector. Let's change the value to 100 and run play mode. But now we are facing a challenge. We have a string variable we can change in the inspector, but we want to show a number of people. Numbers are an integer data type. But we can't simply change the data type in an integer. If we do, we get an error. Lucky for us, there's an easy way to change an integer to a string. We do this by adding a function after the variable name, .toString, and quotations. We'll get back to functions later on, but for now it's enough to know that this function changes an integer to a string. But only there where you use it. The variable itself is still an integer. Now we can test this change in the editor. It looks like nothing is changed, but it does. We can now add a functionality to change the variable. But first let's change the name of the integer variable. The name text isn't a very good descriptive name. Let's rename to number of people. Be very carefully when you change a name of a variable. Visual Studio throws an error everywhere you have used the old name. You have to change it everywhere you have used it. I'll introduce the concept of a function to you. A function is a little chunk of code you can run at a specific time. Under the update method, above the last curly bracket, we are going to place our first function. We need to access the function outside the script. So we start with the keyword public, then place the keyword void, then we give the function a name. Sum up. Right after the name, no space, we place a double parentheses. We end with a curly brace and press enter. Visual Studio will automatically place the curly brackets in the correct way. Between these curly brackets we can place our code. We can test this out by adding a debug.log statement here. If we enter play mode, we'll see no message appear in the console. Everything else works, but the console remains empty. This is no error. We have written a function, but we never called the function. The code gets never reached. To test the function, we can place the function call in the start method. This is done by putting the name in double parentheses followed by a semicolon. That's it. Let's test it again in the editor. Nice, the function and the function call works. But we don't want to return to sending messages to the console. We want to give the function another purpose. We want to add 1 to the number of people. Let's remove the debug.log statement Adding 1 to a variable can be done by variable equals variable plus 1. Let's test if this works in the editor. When we keep an eye on the value of the variable number of people, we can see this change from 100 to 101, but we don't see it change in the game view. This is easy to explain if we take a look at the start method. Code in a script is run line by line. So in the start method we run the statement that changes the text property of the text container. And after this, the function SumUp is called. We change the value but we never change the text property after it is changed. A way to solve this issue is to update the text property after the function get called. But a better way is to add the update of the text property at the place where the value gets changed. If the function gets called from another place, the text property is automatically in sync. This should work. And luckily it does work. But we want to let the user control when the number of people is increased by 1. In our script this is done by calling the SumUp function in the start method. We need a way to interact with the user. Interacting with a user is done with an UI element. In this case a button is the right choice. Let's add a button on the canvas. By right-clicking on the canvas in the hierarchy, select UI and then Button. As you can see, the text component and the button overlap each other. We need to place the button a bit down. If we select the button in the hierarchy and change the position of the Y value to -250, the button is lowered. The button has its own text component. It currently holds a value of button. We can change this value if we select the little triangle in front of the button in the hierarchy. The text component is visible. We'll change the text from button to add 1. Maybe you have noticed the text component isn't centered correctly. I'll show you how to change this. Just select the text component in the hierarchy and change the alignment in the inspector to center and middle. The game view looks great. We have a text component of which we can change the text property through the counter script. And we have added a button with the text add 1. If we run play mode, we can select the button. It's as made visually when you click the button, but nothing more happens. What we need is a way to make something happen. When we press the button, well, we can add a function to the button. So we can attach our SumUp function in our counter script. Select the button in the hierarchy. In the inspector window, scroll to the part where you can see on click. Here you can press the plus icon in the field that says non-object. Drag the canvas object from the hierarchy to this field. Now you can press the drop-down menu that says no function. We can select the counter script. Because the counter script is attached to the canvas, select the SumUp function from the drop-down menu. The SumUp function appears here because we made it public in the counter script. Only a few things to do. First, change the value of the number of people variable to 0. And in the counter script, we need to remove the SumUp function call in the start method. That's it, it all comes together. Let's test it in the editor. If we press the Add 1 button, the number of people value changes by 1 every time you click it. We have a nice functioning app. But we can add a few things to make it a bit nicer. The first thing we can add is a reset button. With the gained knowledge, this should be easy. It's a great way to repeat the steps to anchor the knowledge. Since this is a repetition of steps, We will go through the actions a little faster. Let's start by adding a new button on the canvas. To distinguish the two buttons, let's rename the new button to Reset Button. The new Reset button is placed in the center of the canvas. We have to play with the X and the Y positions of both buttons to place them equally divided on the canvas. The text property of the new button holds a value of button. We'll open the button's child game object and change the text to reset. That's it for the canvas. Now open the counter script. We need a new function that we can attach to the reset button. Therefore, we'll declare a new public function. We'll name this function resetSum. Inside the curly brackets, we can set the number of people variable to a value of 0. This will reset the value to 0. But it's not visible on the text component. So we need to update the text property of the text container. Don't forget to save the script. Now return to the editor to hook this function to the reset button. Select the reset button and scroll to the onClick property. In the inspector window, select the plus icon and drag the canvas game object from the hierarchy in the empty field. Now we can select the resetSum function in the counter script. Let's test the reset button. The reset button works. We can reset the counter to 0 when we press the reset button. One thing I am missing is a description of what we are incrementing when we press the Add One button. The variable is named number of people, but it's not shown in the text. We only see a number, not what the number represents. Let's fix this in the counter script. Remember how we can add to string variables. If we place a plus icon, the second string value is attached to the first. That's just what we'll do after the text container's text value. We add a plus icon and between quotation marks the text number of people. To make sure the text is always in sync, we need to do this everywhere we change the value of the text container. If we test this in the editor, we'll see it works, but it looks like crap. There needs to be a space between the number and the text, and we want the text to be on one line. Let's first fix the one-line issue. If we change the width of the text component from 200 to 500, maybe this is enough. While in play mode, we can test if a width of 500 is enough. Remember that what you change in the inspector while in play mode doesn't get saved. To add the space between the number and the description, just simply add it in the script. To end this lesson, I want to add a header for the app. A text component with a value that doesn't get changed in the script. Place the text component at the top. Align the text in center and the middle. Change the text. Adjust the width. Test. Project and Lesson 2. Done. Great work. Please like and subscribe, so you'll get notified if a new video is uploaded. More people will get this video in their search result when they want to learn Unity game development. Thanks for watching. In the next lesson, we'll start using 3D game objects in combination with the Unity physics system.